right, today we are starting section 1.2, and actually we're going to spend 2 days on section 1.2. So today is just going to be day 1 of notes, and we're going to be talking about angles, at least, just angles. I don't know why it says segments and angles, because it's mainly angles. So you are familiar with angles. I know you've seen angles before. We've already talked about how to label angles, but now we're talking more about measurements. So we can measure them with a protractor. I'll show you one in class, but it's that thing that looks like that, and we're looking at all the numbers. And as far as we're concerned in this course, we're only going to be talking about a measurement of degrees. In future courses, you'll learn some other ways, but in here, just degrees. Now, we're going to talk about some different classifications. An acute angle is just that. It's little and cute. It's an angle that measures between 0 and 90 degrees. And so, in other words, 0 degrees, the angle is greater than 0 degrees, but less than 90 degrees. An example of what one might look like is this. It's an angle that measures less than 90 degrees. A right angle looks something like this. Now, you can't just go by the way it looks, like, oh, that looks like a 90-degree angle. In order to know for sure, it must have that symbol, that little square in the corner. Then you know it's a right angle. So it's an angle that measures 90 degrees. That's it. An obtuse angle, an example of what one might look like, is something like this. It's big and obtuse. It's an angle that measures between 90 degrees and 180 degrees. So 90 degrees, angle 180 degrees. And finally, a straight angle it looks like a straight line. It's an angle that measures 180 degrees. So what one might look like, it looks like a line. We'll put some points on there. So this is angle ABC. It looks like a line. Now, something, terminology you probably have not heard before is congruence. And this is where it gets a little funky, and there's going to be so much language in this course. So we're used to equality. Now, equality is when we talk about measurement. So we use equal when we talk about measurements. Two angles are equal if they have the same measurement, or two segments are equal if they have the same measurement. Congruence, which we use this symbol, that's the symbol. Congruence just means that they're exactly the same. So if we say that two angles are congruent, it means they're exactly the same, or in other words, they have the same measurement. So that's what we have right here. Maybe I'll switch colors, get some variance here. So congruent angles are angles that have the same measure. And so I'll try to draw two congruent angles here. So we have this one, and then maybe I'll draw it so it looks like this. So we could say angle A, we'll say it's about 60 degrees, and angle B is 60 degrees. And we would say angle A is congruent to angle B which means the measure of angle A is equal to the measure of angle B. And that's a lot to take in. Notice when we use the angle symbols, we say congruent. But if we talk about measurement, we use the little m there, and then we use equal. Similarly, for these segments, maybe we have segment XY, and we have another segment XY. Oh no, not the same. AB, we'll call it. And we would say segment XY is congruent to segment AB, but that means the measurement of XY is equal to the measurement of AB. Notice no lines. When we talk about the measurement, no lines with the measurement. So it's kind of like the distance between points X and Y and the distance between points A and B are equal. So all these little notation things we're going to get used to, and you will learn it with practice. It says, so a lot of times we use tick marks or extra lines to indicate congruent measures. So here we have, like, this angle is congruent to this angle, so we could say angle K congruent to angle T. We also can see here that, say, HG with this little mark is congruent to SR with that little mark, so we can say segment HG is congruent to segment SR. And then over here, they don't use tick marks on the angles, but just, with the one line, angle W congruent to angle X. And then similarly with these two tick marks here and these two tick marks there, we would say WZ congruent to XY. Notice I also, like, W goes with X, so I say WZ XY, that the corresponding parts match up. Now, because we can measure angles and segments, we can add them together. So the angle addition postulate, if two angles are adjacent, in other words, they share a side, they're right next to each other and they share a side, the two smaller angles can be added to find the measure of the larger one. So an example of this could look something like this. Let's do this. Let's do this, and we'll call this A, B, C, D. So angle ABC plus angle CBD is equal to angle ABD. So the two small ones added together equal the big one. Same is true for segments. We could have something that looks like this. AXB. We would say segment AX plus segment XB is equal to segment AB. So, let's use these postulates to figure some things out. Let's do some math. So in this first picture, it does say that angle ABC is a straight angle. So we know that the measure of angle ABC is equal to 180 degrees. And with segment addition, we know then that this angle plus this angle has to equal 180 degrees. So we can write that equation. We could say 5x plus 10 plus 2x minus 5 is equal to 180 degrees. And now we can do some algebra. Minus 5, 7x equals 175, 7x equals 25. Now, in geometry, it can be tricky. In algebra, all the answers we were looking for looked like x equals something. In geometry, you always have to make sure. Sometimes they'll say find x. In this case, the instructions are find the measure of angle DBC. So the measure of angle DBC is 2 times x, which is 25, minus 5. So 50 minus 5, or 45 degrees. And that is your final answer. So always read the problem. Make sure you're answering the question. Okay, finally, we have angle D is obtuse. What are the restrictions on the measure of angle D? So, I guess this is angle D. We'll put it like that. So we know if it's obtuse, angle D, this 2x plus 6, has to be between 90 and 180 degrees. And so now when we solve it, we're going to subtract 6 from all parts. And that's going to give us 84 less than 2x less than 174. Dividing everything by 2, we get 42 less than x less than 87. So the restrictions on D, I guess I could have said angle D has to be in between 0 and 180. That's what we started with. And then the restrictions on x are such as that.